Hi, this is Thomas. Welcome back to math class. This is lesson 2 on integration. In this lesson, we're going to learn more integration rules. To begin, let's review rules that we learned in our first lesson. We learned the reverse power rule, which is the integral of x to the power of n with respect to x equals x to the power of n plus 1 over n plus 1 plus our integrating constant of c. We also saw the constant rule, which is the integral of k, a constant, with respect to x, is k times x plus c. So anytime I'm dealing with integrating an expression with a constant value, I will treat that as the constant value as a coefficient of the variable I'm working with, in this case x. So these two integrals are review. Let's learn some additional integrals. For exponents, the integral of working with e to the power of x with respect to x is e to the power of x plus c. As the derivative of e to the power of x is e to the power of x, the integral of e to the power of x, going backwards, is e to the power of x plus the integrating constant c. Now from exponential functions, let's consider the inverse, logarithmic functions, and integration. In this case, I'll go to my result to begin. What do I integrate to get the natural log of x plus c? In doing differentiation, the derivative of the natural log of x is 1 over x. And the integral of 1 over x with respect to x is, with one slight adjustment, the natural log of x plus c, actually the natural log of the absolute value of x plus c. Notice that 1 to the power of x is equal to x to the power of negative 1. Now, if we wanted to use the reverse power rule for x to the power of negative 1, we would end up with, if we try and take the integral of x to the power of negative 1 with respect to x, we're going to end up with x to the power of negative 1 plus 1, which is 0, over n plus 1. Negative 1 plus 1 is 0. And that's not a valid result. We use the reverse power rule when n does not equal negative 1. If n equals negative 1, then we're going to use the integral rule, which is the integral of 1 over x with respect to x is the natural log of the absolute value of x plus c. And now integration relating to trigonometric functions. We're going to look at 3 integral rules. And let's start with the result in all 3 cases. First, the result of sine x plus c. Now, from the right side to the left, it's like performing differentiation. When I go from the result to the integral statement, it's like differentiation. So what is the derivative of sine of x? The derivative of sine of x is cosine of x. Thus, the integral of cosine of x with respect to x is sine of x plus c. Let's do the same with cosine of x. Now when I go from cosine of x as a function to the differential, I have negative sine of x. In this case, I want my first statement to be positive. So if I'm integrating sine of x with respect to x, the result is negative cosine of x plus c. And let's consider what produces a result of tangent of x plus c. The derivative of tangent of x is secant squared x. Thus, the integral of secant squared x with respect to x is tangent of x plus c. In these examples, we see the concept that integration is the reverse process of differentiation. Now let's look at some additional differentiation concepts and see how they translate into integration concepts. Let's start with the constant multiple rule. The integral of 5x to the power of 4 with respect to x equals 5 times the integral of x to the power of 4 with respect to x. I can pull the constant multiple through the integral sign. I continue to integrate. This will be 5 times x to the power of 4 plus 1 over 4 plus 1, which is 5 times x to the power of 5 over 5, which equals x to the power of 5. Next, let's consider the addition rule. The integral of 5x to the power of 4 plus 3x to the power of 2 with respect to x is the integral of 5x to the power of 4 with respect to x plus the integral of 3x to the power of 2 with respect to x. We can now apply the constant multiple rule. 5 times the integral of x to the power of 4 with respect to x plus 3 times the integral of x to the power of 2 with respect to x. I already know the simplification of the first integral, which is x to the power of 5. That's on the left side of the screen. What I see isn't on the left side of the screen, which I missed and we need our integrating constant for the constant multiple result, x to the power of 5 plus c, and now continuing with our addition rule result. So I know that my first integral is x to the power of 5 because it's the same integral as I work through in the constant multiple example. And then continuing with the second integral, plus 3 times x to the power of 2 with respect to x is going to be plus 3 times x to the power of 2 plus 1 over 2 plus 1, or plus 3 times x to the power of 3 over 3, or x to the power of 3. So in my final integral, the result x to the power of 5 plus x to the power of 3 plus c. Now, product rule and quotient rule. None. If you are working with products or quotients, you simply work through the multiplication or division and then continue with your integration. For example, the integral of x squared times 8x is going to be the, with respect to x, is going to be the integral. I'm not going to use the product rule, I'm simply going to multiply. This will be the integral of 8 times x to the power of 3 with respect to x. And I'll apply my constant multiple rule. 8 times the integral of x to the power of 3 with respect to x. And now I'll integrate. This is 8 times x to the power of 3 plus 1 over 3 plus 1, which is 8 times x to the power of 4 over 4, which is 2 times x to the power of 4 plus c. So for product and quotient rules, there aren't product and quotient rules. You simply multiply and then integrate, or divide then integrate. With regards to the chain rule, there is a type of reverse chain rule known as the substitution method of integration, which isn't required content on the IGCSE 0606 paper. But there is one more function form that is required content on the exam relating to integration, and we'll see that form in the next video.